Hi guys, today I'm going to prove the quotient rule, namely u over v prime. And so we could prove this using the definition of the derivative, but that would be actually pretty long and pretty difficult. So instead, we're going to use the product rule that suppose we already know it. And so this is how we do it. So u over v prime is actually equal to u times 1 over v prime. And so this is here we're going to use the product rule, and the product rule is first prime times second, so it's going to be 1 over v, and then plus first times second prime. Okay, and now how do we deal with 1 over v prime? Well, so v is a function, so suppose it's a function of x, and let's just try to write it over here. So suppose that 1 over v is just a function of x. So let's write v of x, actually, to make it more clear. Now, actually, this is just v to the power of minus 1 of x, right? And so how do we find the derivative of something to the minus 1 power? Well, it's going to be minus 1, right? We just use basically the power rule. And so it's going to be minus 1 times v to the power of minus 2 of x. But don't forget that v is a function, right? So don't forget that we have to use the chain rule here and multiply this by v prime, because v is a function. We have to use the chain rule. So that equals to negative, because we have minus 1. Then at the top we're going to have v prime, and at the bottom we're going to have, because it's a v to the second v to the power of negative 2, so we're going to have v squared at the bottom. And that's pretty much it. So now you just set this aside, and we're going to use that above, and so that equals, the above part equals u prime v plus, u prime 1 over v plus u times, and so what we found here is negative v prime over v squared, and that will give us, so we want to set this to the common denominator, so we're going to multiply by v here and here, and so what we're going to get is u prime v, and so we have minus over here, so we're going to have minus u v prime, and all of that over v squared. And that, ladies and gentlemen, is the answer. So as you can see, it's a pretty easy proof, much easier than if we used the definition of the derivative, using the limits. Okay, thanks for watching.